Hello, my name is Kenneth Mayfield, and for this project, ASL Avatar Learning and Real-World Industrial Interaction, I'm partnering with CarbX Core. CarbX Core is an innovator of carbon capture technology, as you can see here. Now, what they've built is a device that captures carbon from the air and can convert it into building materials in the real world. What we've been building together with the generous support of Deep Funding Round 1 is a metaverse-style learning environment that you can see here to learn about the objects themselves, to see them on site in terms of, starting my timer, in terms of how you can learn how to use the CarbX technology itself. So in terms of the presentation, we've been trying to build in a more equitable experience. We do have some support for deaf and hard of hearing that we've begun in round 1. We're now finalizing, which is ASL recognition, American Sign Language. Now, the difficulty with sign language is that it's multi-layered and multimodal. You have a very rapid movement of arms and face and expression to put together sentences. It's a different style of communication. You have to prepare novel ideas, shorthand them, and then describe them to an audience. Now, what we have in the CarbX metaverse is an ability to speak. You can have speech to text and query avatars directly. But what we're missing is access for gesture recognition in terms of American Sign Language. We believe that 20% of the world's population should have similar access to hearing individuals. So the problem of ASL motion capture is complex. People have been working on this since 1989. Video capture, as it stands presently, is doing a relatively good job, but is very slow in terms of some of the very quick gestures that sign language will use. This would mean choose one of A, B, C, or D. Facial capture involves usually putting a camera about this far from the speaker's face. But if you're signing, that becomes an obstruction in terms of it, and it also obstructs the face. And desktop sensors are technically too difficult to set up. Now, here we have an example of video to speech sign language. And Anya here is displaying some nonverbal information in terms of her face, but also the beginnings of an alphabet. And we have problems with obstruction. This is a real signer, an interpreter who's created material for us. And you will see that she moves quite quickly in terms of what she's describing once she moves to actual sentences. Now, where we're at in terms of development is webcam capture of gestures, alphabet, and body pose. This is Ganesh's work on the left. On the right is what we use for desktop capture with sensors on 2 axes. Now, where we need to go is to improve the machine learning model's recognition of ASL via webcam, which will be the end user's technology of choice. We're starting with the alphabet, numbers, and simple command phrases. And if we're fortunate enough to receive Deep Funding 3's support in this endeavor, then we'll be able to start building out the vocabulary of that ASL recognition and hopefully get to short sentences of 1 or 2 people, or 1 or 2 words, pardon me. Okay. In terms of learn and earn, I'll cover this quickly. CarbX has the ability to produce real-world samples. And within SingularityNet, we'd like to work with AGIX to build a learn and earn scenario where people will build out examples of the use of carbon capture technology. We print real samples that will be sent to them, and individuals earn AGIX in this fashion. Yeah. Okay. And there we are. Which time have we reached?
You have 1 minute left, Ken.
Excellent, excellent. Okay, now to speak in terms of the ASL recognition, ideally we'd like to be able to capture a full bodysuit, but we need a kind of custom rig. In terms of the data set we're using, we found a Microsoft ASL data set with 20,000 sentences that we're going to use to train our model in round 1. If we're fortunate enough to receive funding for round 2, then we'll be able to develop that vocabulary further. and build up the inclusion of ASL. Now, ASL is a very difficult nut to crack. People have been working on it for decades. And the difficulty comes in terms of the acceptability to ASL speakers. And that depends on where they learned, how long they've been practicing, and generally how old they are. It's found through study that older individuals tend to reject an avatar, but younger individuals who are brought up on gaming find it more acceptable. And our approach with SingularityNet will be to inch that forward at a steady pace so that we build out something that's really solid and bona fide for SingularityNet's AI, AGI contribution to the world in terms of ASL recognition.